The trajectory of modern armored warfare has been defined not by the clash of Titan empires on the plains of Europe, but by the jagged, unpredictable violence of asymmetric conflict in the developing world. For the better part of the 20th century, military doctrine prioritized the main battle tank and the tracked infantry fighting vehicle. These platforms were designed for high-intensity, peer-to-peer conflict, prioritizing frontal armor protection and offensive firepower to defeat similar adversaries. However, the post-Cold War era, and specifically the conflicts following the invasions of Iraq and Afghanistan, revealed a glaring vulnerability in this doctrinal approach. The primary threat to mechanized infantry ceased to be the kinetic penetrator of a rival tank and became the buried, improvised explosive device, the directional mine, and the roadside ambush. In this new theater of operations, the heavy tracked armor of the Cold War proved frequently ill-suited. It was logistically burdensome, politically aggressive in appearance, and often vulnerable to the massive upward blast forces of buried charges which could shatter hulls designed primarily to deflect horizontal impacts. The solution was the Mine-Resistant Ambush Protected Vehicle, or MRAP. While the United States and NATO scrambled to field tens of thousands of these vehicles, a parallel and quieter evolution was taking place in the East. The People's Republic of China, transitioning from a localized defensive power to a global economic and military stakeholder, recognized the necessity of such a platform. As Chinese interests expanded into Africa via the Belt and Road Initiative, and as the People's Liberation Army increased its contributions to United Nations peacekeeping missions, the requirement for a vehicle capable of surviving the mine-strewn roads of the Sahel and the Horn of Africa became acute. This brings us to the answer to that requirement: the Charlie Sierra Victor Papa III, colloquially known as the Bigfoot. Developed by Poly Technologies, a state-owned defense giant, and manufactured by Changan Automobile, this vehicle represents a fascinating case study in technology transfer, strategic adaptation, and the good enough engineering philosophy that characterizes China's export defense material. It is a vehicle born of South African DNA, powered by American-derived commercial automotive technology, and battle-tested in the harsh insurgencies of Nigeria and Somalia. The Bigfoot is the armored vehicle nobody expected because it deviated from the traditional Chinese export model of mass-produced, Soviet derivative tracked armor. Instead, it is a specialized, wheeled counterinsurgency platform that has quietly become the backbone of protected mobility for several African nations. To fully understand the engineering and doctrinal roots of this vehicle, one must look beyond Beijing to Pretoria. South Africa is widely acknowledged as the spiritual home of the mine-protected vehicle. The overarching design philosophy that governs the Bigfoot is a direct inheritance from the South African border war of the 1970s and 1980s. Faced with a chemically energetic border region infested with Soviet-supplied anti-tank mines, the South African Defense Force realized that conventional flat-bottom vehicles like Land Rovers and Bedfords were death traps. South African engineers, through necessity, pioneered the V-hull concept. They discovered that by shaping the hull floor into a sharp V, the vertical blast wave of a detonating landmine could be deflected laterally away from the crew compartment. This geometry, combined with a high center of gravity and sacrificial suspension components, became the blueprint for survival. Vehicles like the Caspier and Buffalo achieved legendary status for their ability to protect occupants from massive explosive yields. In the late 2000s, China's Poly Technologies sought to modernize its export portfolio. While the PLA possessed capable wheeled armored personnel carriers, these were fundamentally conventional designs with limited mine protection. China needed a shortcut to MRAP competency to meet the growing demands of its African client states and its own peacekeeping deployments. They found this shortcut in Mobile Land Systems, a privately owned South African defense firm specializing in mine-protected vehicles. The specific object of Chinese interest was the Caprivi Mark I, a robust MRAP designed for the rugged terrain and logistical austerity of the African bush. The Caprivi was not the most technologically advanced vehicle in the world. It lacked the independent suspension and digital backbones of Western counterparts, but it was tough, repairable, and highly survivable. Negotiations between Poly Technologies and Mobile Land Systems concluded in 2009 with a comprehensive technology transfer agreement. The deal, valued at approximately 40 million South African rand, roughly $6 million at 2010 exchange rates, was a masterclass in China's absorb and iterate industrial strategy. The contract provisions included hardware transfer, where Mobile Land Systems provided 3 complete Caprivi Mark I vehicles for immediate testing and evaluation by Chinese engineers. Manufacturing knowledge was transferred through 9 additional vehicles supplied in knockdown kits, allowing Chinese technicians at Changan Automobile to practice assembly and understand the vehicle's intricate welding requirements. Crucially, Poly Technologies acquired the licensing rights to manufacture the vehicle domestically in China and market it globally. The agreement included training programs where South African engineers instructed their Chinese counterparts on the nuances of blast physics and V-hull fabrication. This transfer allowed Changan Automobile, one of China's Big Four automakers, to establish a production line for the Charlie Sierra Victor Papa 3 rapidly. By 2012, the vehicle was ready for its public debut. It was unveiled domestically at the China International Aviation and Aerospace Exhibition in Zhuhai, and internationally at the Defense Services Asia Exhibition in Kuala Lumpur, Malaysia. While the vehicle is genetically a Caprivi, it is not a clone. Chinese engineers at Poly Technologies and Changan Automobile applied their own modifications to suit their domestic supply chains and export strategies. The hull geometry remained largely faithful to the South African design. The physics of blast deflection do not change with geography, but the automotive components were swapped for those readily available within China's massive commercial trucking ecosystem. The most significant alteration was the substitution of the original powertrain with Chinese-manufactured equivalents, specifically licensed versions of Cummins engines produced by joint ventures in China, and proprietary transmission systems. This localization strategy reduced the unit cost significantly, allowing Poly Technologies to offer the vehicle at a price point that Western competitors could not match. The vehicle was marketed aggressively as the Bigfoot, a name likely derived from its massive tires and aggressive stance, but also serving as a memorable brand for non-Chinese-speaking markets. The defining characteristic of the Bigfoot, and indeed any MRAP, is its hull. The vehicle utilizes a monocoque V-shaped hull, a construction method where the armored body itself serves as the structural frame, eliminating the need for a separate chassis ladder. This design choice is critical for 2 reasons: weight reduction and blast integrity. In a chassis on frame design, the blast wave can separate the cabin from the frame. In a monocoque, the entire vehicle reacts as a single unit. The V shape is not an aesthetic choice, it is a geometric solution to a physics problem. When a landmine or improvised explosive device detonates under a flat-bottomed vehicle, the rapidly expanding gases impact the floor plate at a 90-degree angle. This transfers the maximum amount of kinetic energy to the vehicle, launching it into the air and transmitting lethal vertical acceleration to the spines of the occupants. The Bigfoot's hull features a pronounced V with an angle designed to deflect this blast wave laterally. By angling the hull floor, the vehicle forces the expanding gas and debris to slide off the sides rather than impacting squarely. The geometry decomposes the vertical force vector of the blast into a smaller vertical component and a horizontal component that dissipates into the air. The high ground clearance of roughly 0.38 meters increases the distance between the explosive source and the hull. Since blast pressure decreases with the cube of the distance, every centimeter of height provides an exponential increase in survivability. The hull is constructed from all-welded ballistic steel. Unlike composite armors, which can be brittle or ceramic armors which shatter upon impact to dissipate energy, steel provides resilience and multi-hit capability. It is durable, repairable in the field with standard welding equipment, and resists the environmental degradation common in tropical climates. The base vehicle offers protection ranging from European Standard B6 to NATO Level 3B. Level 1 provides basic protection against standard ball ammunition at 30 meters. Level 2 protects against armor-piercing incendiary rounds. Level 3 protects against armor-piercing rounds with tungsten carbide cores. The base hull is typically cited as resisting ball ammunition, but with the capability to withstand armor-piercing rounds when up-armored. The vehicle is modular. Poly Technologies offers bolt-on armor packages that can upgrade the protection level to roughly Level 4. This protects against 12.7 millimeter heavy machine gun fire, a common threat in conflicts where technicals armed with heavy machine guns are prevalent. This modularity allows operators to tailor the weight of the vehicle to the threat environment, lighter for patrols in low-risk areas to save fuel and suspension wear, heavier for convoy escort in bomb-heavy zones. The vehicle's primary selling point is its resistance to mines, a direct legacy of its South African DNA. The manufacturer claims specific resistance metrics that place it firmly in the MRAP category. The underwheel protection rating means the vehicle can withstand a blast equivalent to 16 kilograms of TNT under any wheel. This is a massive amount of energy, roughly equivalent to 2 stacked anti-tank mines. The suspension components are designed to be sacrificial. They will shear off upon impact, absorbing energy in the process, while the hull integrity remains uncompromised. The hull center is rated for 8 kilograms of TNT. This protects against centerline improvised explosive devices. While 8 kilograms is less than the underwheel rating due to the closer proximity to the crew, it is standard for vehicles in the 15-ton class and sufficient to survive most standard anti-tank mines. Before we continue, I want to ask you something. Have you ever seen this vehicle in real life? Maybe you've spotted it during peacekeeping operations or military parades. Drop a comment below and let me know. And if you're enjoying this deep dive into military technology, don't forget to hit that like button and subscribe to the channel so you don't miss any of our future videos on armored vehicles and defense technology from around the world. Visibility is often the weak point in armored vehicles, creating a bunker syndrome where the crew cannot see threats. The Bigfoot features large, multi-laminate bulletproof windows. These are likely glass polycarbonate composites designed to catch the bullet in the outer hard glass layers, while the inner polycarbonate layer prevents spalling, glass shards, from injuring the crew. Integrated into the center of these windows are circular firing ports. These allow the infantry inside to engage targets with their personal weapons without exposing themselves. While firing from a moving vehicle is notoriously inaccurate, this feature provides psychological comfort and suppressive fire capability, essential for breaking ambushes in close terrain like urban centers or dense forests. A 15-ton armored box is strategically useless if it cannot move effectively. The mobility systems of the Bigfoot reveal the most about its Chinese industrial origins and the compromises made to achieve its low price point. Unlike Western MRAPs, which often feature custom-built powertrains, the Bigfoot leans heavily on commercial off-the-shelf technology from China's booming heavy truck sector. Official brochures and online entries typically list the engine simply as a diesel engine of unknown type delivering around 260 horsepower. This ambiguity is typical of Chinese defense exports, where specific supplier relationships can be sensitive or subject to change based on batch availability. However, a forensic analysis of the supply chain, performance specs, and visual evidence points to a specific culprit, the Dongfeng Cummins series. The prime suspect is the Cummins ISD 28530. This engine is manufactured by Dongfeng Cummins Engine Company, Limited in China. It is a 6.7-liter, inline 6-cylinder, turbocharged diesel engine delivering 210 kilowatts at 2,500 revolutions per minute. The torque output is 970 Newton meters at 1,400 revolutions per minute. Torque is the critical metric for moving a 15-ton vehicle through mud. The emission standard is Euro 3. This is crucial. Western military engines often struggle with the high-sulfur, dirty diesel fuel found in conflict zones like Nigeria or Somalia because their emission systems clog. The Euro 3 standard is robust enough to handle lower-quality fuel, a deliberate choice for an export vehicle destined for the developing world. At a combat weight of 15,000 kilograms and a presumed horsepower of 260, the vehicle has a power-to-weight ratio of approximately 17.3 horsepower per ton. A modern Western infantry fighting vehicle typically aims for 20 to 25 horsepower per ton. A civilian sedan has over 100 horsepower per ton. 17.3 horsepower per ton is adequate for road travel, allowing the vehicle to reach its governed top speed of roughly 90 to 100 kilometers per hour. However, it suggests the vehicle is sluggish off-road, slow to accelerate, and struggles on steep gradients. This aligns with operational reports from Nigeria describing the vehicle as lumbering. In an ambush, acceleration is survival. The inability to sprint out of a kill zone is a tactical liability. Operational feedback from Nigeria indicates that reliability, specifically regarding the engine, has been a mixed bag. A common and debilitating failure point in MRAPs deployed to the Sahel is overheating. Armoring a vehicle adds immense weight, which puts a constant high load on the engine, essentially forcing it to drive uphill all the time. Furthermore, to protect the engine from bullets, the radiator is often shielded by armored louvers or placed behind a ballistic grill. This severely restricts airflow. In the 45 degrees Celsius heat of Borno State, a 6.7-liter diesel engine dragging 15 tons of steel through sand at low speeds generates massive waste heat. If the cooling package is not significantly upsized from the commercial truck baseline, the engine will overheat. Overheating triggers the engine's protection mode, drastically cutting power or shutting the engine down entirely. In a combat zone, a vehicle in protection mode is a stationary target. The vehicle's reliance on commercial derivative engines means the cooling system is likely the Achilles heel unless specific tropicalization kits with larger radiators and high flow fans were installed. The transmission is likely a robust manual or automatic gearbox mated to a 2-speed transfer case. The availability of a manual transmission option is likely, given the training levels of some export customers, though automatics are preferred in MRAPs to allow the driver to keep both hands on the wheel during rough terrain maneuvers. The Caprivi Mark I parent design was built for simplicity. While modern high-end MRAPs use independent double wishbone suspension for superior ride quality and speed, the Bigfoot is a budget-conscious platform. Technical descriptions of the vehicle as fully suspended combined with its visual profile, high ground clearance, and truck-like stance strongly suggest a heavy-duty leaf spring or coil spring solid axle setup. Solid axles are incredibly durable, simpler to maintain in the field, and maintain constant ground clearance under heavy loads. They are the Bigfoot's ankles, thick, heavy, and hard to break. However, the ride quality is poor. Solid axles transmit road shock directly to the frame. In an MRAP, this contributes to crew fatigue. A soldier bounced around in a steel box for 8 hours is less effective in combat. The Bigfoot name is earned by its massive run-flat tires, likely 14.00 R20 or similar heavy tactical size. High-end variants are equipped with a central tire inflation system, allowing the driver to lower tire pressure from the cab to traverse soft sand or mud. This is crucial for the Nigerian Army in the rainy season when the unpaved areas turn to quagmires. Lowering pressure increases the contact patch, preventing the 15-ton vehicle from sinking. The tires contain composite run-flat inserts. If shredded by small arms fire or shrapnel, these inserts support the rim, allowing the vehicle to limp out of the danger zone at reduced speeds, usually 50 kilometers per hour for 50 kilometers. The interior of the Bigfoot is a study in utilitarianism. It is not designed for comfort, it is designed for capacity and survival. The layout and ergonomics reflect the vehicle's dual role as a transport and a fighting vehicle. The vehicle follows a standard armored personnel carrier layout, optimized for maximizing troop carrying capacity within the V-hull constraints. The crew compartment at the front has the driver on the left and the commander on the right. They are separated by the engine transmission tunnel and the central console. Visibility is provided by two large armored windscreens. The troop compartment in the rear seats 10 soldiers. The soldiers sit on inward-facing bench seats or individual seats running down the sides of the hull. Inward-facing seating is less optimal for situational awareness. Soldiers are looking at each other, not at the firing ports or the terrain, but it allows for the most efficient use of space and easier communication within the squad. Crucially, in a proper MRAP, the seats are not attached to the floor. They are suspended from the roof or the side walls. This floating design decouples the occupant from the floor plate. When a mine strikes, the floor deforms and accelerates upward violently. If the seat is bolted to the floor, that energy goes straight into the soldier's spine, causing compression fractures or death. If suspended, the shock is dampened by the strap system or energy-absorbing mounts. The Bigfoot uses this suspended seat philosophy to meet its survivability ratings. A critical look at the dashboard reveals the commercial roots of the vehicle. The instrument cluster, steering wheel, and switchgear are often lifted directly from Dongfeng or Changan commercial trucks. This provides familiarity for conscript drivers who may have driven civilian trucks and ease of replacement parts sourcing. However, these plastic components are not ruggedized for military use. A common complaint in Chinese export vehicles is that while the armor holds, the soft components, door handles, window switches, air conditioning knobs, and gauge clusters break under the vibration and stress of combat operations. In the operational theaters of Nigeria and Kenya, the air conditioning system is not a luxury, it is a life support system. The interior of a steel box sitting in the African sun can reach 60 degrees Celsius within minutes. Combine this with the body heat of 12 soldiers in body armor, and the temperature becomes lethal. Heat stroke can incapacitate a squad before they ever see the enemy. The dashboard features prominent climate control vents. However, the efficiency of this system is tied to the engine's cooling capacity. If the engine overheats, the air conditioning compressor is often the first load to be shed or fail, leading to rapid degradation of crew performance. The crew, driver, and commander have heavy side doors. The troops enter and exit via a single large hydraulic ramp or swing door at the rear. The ramp facilitates rapid deployment of a full squad, but relies on hydraulics which can fail. A manual override door is usually integrated into the ramp. Roof hatches provide an alternative exit if the vehicle rolls over or the doors are jammed. Relying on a rear door is standard for armored personnel carriers, but if the vehicle is disabled in an ambush, the rear exit can become a fatal bottleneck if targeted by enemy machine gunners. The Bigfoot is primarily a battle taxi, designed to get troops to the fight, not to fight the battle itself like an infantry fighting vehicle. However, in counterinsurgency operations, the vehicle often acts as a mobile pillbox, providing fire support for dismounted infantry. The roof features 1 or 2 turret rings or hatches. The forward position is typically armed with a 12.7 mm heavy machine gun, such as the Chinese QJC-88 or the older W-85. This weapon is analogous to the Western M2 Browning or the Russian DSHK. It fires a massive cartridge capable of penetrating engine blocks, shredding technicals, unarmored pickups, and punching through light cover like brick walls. A rear hatch may mount a 7.62 mm general-purpose machine gun, typically the Type 86. The Nigerian Army variants are often seen with a gun shield or an open turret. This offers the gunner some frontal protection, but leaves them vulnerable to snipers from the side and rear and to airburst shelling. The gunner is exposed, head and shoulders out of the vehicle, which is a significant risk factor. More recent deliveries, specifically those to the Philippine Presidential Security Group, feature a significant upgrade: remote-controlled weapon stations. The technology of a remote weapon station allows the gunner to sit safely inside the armored hull, aiming the weapon via a screen and joystick. The system uses cameras, thermal and day-night to target the enemy. This dramatically increases crew survivability. The gunner cannot be sniped. The optics also provide a surveillance capability, allowing the vehicle to act as an observation post without exposing a human observer. Remote weapon station systems are expensive and complex to maintain. Their inclusion on the Philippine models suggests a high-tier variant compared to the manual turrets seen in the Nigerian budget specification. As mentioned, the 10 troops in the back are not passive passengers. The firing ports allow them to create a hedgehog of fire. In an ambush, the standard operating procedure is often to unleash a volume of fire from all ports to suppress the enemy while the driver pushes through the kill zone. While inaccurate, this mad minute of fire can force insurgents to keep their heads down, buying the Bigfoot crucial seconds to escape. Nigeria is the largest and most active operator of the vehicle, utilizing roughly 120 units in the fight against Boko Haram and Islamic State West Africa Province. The vehicle's performance here offers the truest test of its capabilities in a high-intensity conflict. The operational environment in Borno State is brutal. The terrain is a mix of semi-arid scrubland, fine sand, swampy marshes during the rainy season, and the dense vegetation of the Sambisa forest. Conditions include high ambient heat above 45 degrees Celsius, fine dust that clogs air filters and radiators, and poor road infrastructure. The primary threat is the improvised explosive device, often made from unexploded ordnance or fertilizer buried in dirt roads. Ambush tactics involve technicals armed with anti-aircraft guns initiating a firefight after a bomb strike. The Nigerian Army uses the Bigfoot as a convoy escort, patrol vehicle, and troop carrier for clearance operations. Before the Bigfoot, the Nigerian Army relied heavily on the Otokar Cobra, a Turkish light-armored vehicle, and the Toyota Hilux, which was completely unarmored. The Otokar was decent but lacked the mass to survive large improvised explosive devices. The Hilux was a death trap. The introduction of the Bigfoot represented a quantum leap in survivability. There are anecdotal reports and video evidence of the vehicle taking bomb hits and the crew surviving, validating the South African V-hull design heritage. The Bigfoot is valued for its intimidating size and ability to push through brush and small obstacles that would stop a lighter vehicle. However, the lumbering nature of the vehicle makes it a target. Unlike the agile Hilux, which can maneuver off-road to avoid an ambush, the Bigfoot is often confined to the track. If the engine overheats or a tire is blown and the run flat fails, it becomes a static pillbox. There have been instances where disabled Bigfoots were captured by Boko Haram fighters, highlighting the risk of deploying heavy armor without adequate logistics support. Reports suggest that while the purchase price of Chinese equipment is low, the life cycle cost can be high due to parts availability and reliability issues. In some African conflicts, complex vehicles are run until they break and then abandoned, because the logistics chain to China is too slow. However, the use of commercial Dongfeng Cummins engines in the Bigfoot mitigates this significantly. A Nigerian mechanic can likely find parts for a Cummins engine in local truck markets or from cannibalized civilian heavy trucks. This civilian compatibility is a hidden strategic advantage of the Bigfoot compared to Western vehicles with specialized military-only power plants. The Uganda National Police received 35 units in 2016. Here, the vehicle serves a different role: internal security, counter-terrorism, and crowd control. Used by the Field Force Unit, these vehicles are often seen in Kampala during periods of civil unrest. The intimidating visual profile of the Bigfoot is a psychological weapon. Using a 15-ton mine-resistant war machine for police work is often criticized as excessive militarization. However, in volatile regions where criminals or rebels may possess military-grade weaponry, the police justify the armor as necessary for officer survival. The Kenya Police acquired 25 units in 2018. These are deployed primarily to the northeastern border regions to protect against Al-Shabaab incursions from Somalia. Al-Shabaab frequently targets Kenyan police patrols with improvised explosive devices. Soft-skinned land cruisers had previously suffered horrific casualties in these attacks. The deployment of the Bigfoot provided a necessary hardening of the Border Patrol force, allowing them to survive the initial blast and return fire. The delivery of 4 units to the Philippine Presidential Security Group in 2022 represents the high end of the spectrum. Protecting the head of state requires more than just steel. These vehicles are equipped with the remote weapon station mentioned earlier and an electronic warfare suite. This likely includes bomb jammers, electronic countermeasures. These devices broadcast radio frequencies to block the signals used to remotely detonate roadside bombs, for example, cell phone triggers. This integration shows that the platform is capable of hosting sophisticated electronics moving beyond its budget truck roots. To understand the market position of the Bigfoot, we must compare it to its peers. The Bigfoot from China weighs 15 tons with a monocoque V hull and solid axle or leaf spring suspension. It uses a Dongfeng Cummins engine producing 260 horsepower with a power-to-weight ratio of around 17 horsepower per ton. Protection is NATO Level 3B up to Level 4 at a low cost of roughly $500,000. Its primary role is export and peacekeeping. The Caspier Mark VI from South Africa weighs 14 tons with a monocoque V hull and solid axle suspension. It uses Cummins or Mercedes engines with varying power outputs and a power-to-weight ratio of 15 to 20 horsepower per ton. Protection is NATO Level 3 to 4 at a medium cost, serving patrol and counterinsurgency roles. The Oshkosh MATV from the USA weighs 14.7 tons with a monocoque V hull and independent TAC-4 suspension. It uses a Caterpillar C7 engine producing 370 horsepower with a power-to-weight ratio of around 25 horsepower per ton. Protection is NATO Level 4, plus at a high cost exceeding $1 million, serving high-mobility patrol roles. The KAMAZ Typhoon K from Russia weighs 15 tons with a V-hull on frame and independent high-drop pneumatic suspension. It uses a KAMAZ engine producing 350 horsepower with a power-to-weight ratio of around 23 horsepower per ton. Protection is NATO Level 3 to 4 at a medium to high cost, serving as a troop transport. The Bigfoot is essentially a modernized Caspier. It shares the same DNA but benefits from Chinese manufacturing scale. The American MATV is vastly superior in mobility, with independent suspension and higher power. However, it is complex and expensive. For a country like Nigeria, the Bigfoot offers 80% of the protection for 50% of the price and 20% of the maintenance headache. The Bigfoot occupies the sweet spot for developing nations, survivable enough to boost morale, simple enough to fix, and cheap enough to buy in bulk. The proliferation of the Bigfoot highlights a shift in the global arms trade and China's strategic positioning. The Western approach has defense contractors focusing on gold-plated solutions, technologically perfect, networked, and highly capable, but expensive and maintenance-heavy. The Chinese approach, via companies like Poly Technologies, offers the good enough solution. The Bigfoot does not need to be the best MRAP in the world. It just needs to be better than a Toyota Hilux. By leveraging the technology transfer from South Africa and the industrial base of commercial trucking, China has positioned itself as the arsenal of the global South. They are providing accessible survivability to nations that cannot afford American hardware or are barred from buying it due to human rights sanctions. As a state-owned entity, Poly Technologies is not just selling trucks. it is selling influence. The sale of Bigfoots to Nigeria or Kenya creates a long-term relationship involving parts, training, and potential future sales of more complex systems like drones, which Nigeria has also purchased from China. The Bigfoot is an armored vehicle of contradictions. It is a Chinese product with a South African soul. It is built by a state-owned giant but powered by the licensed technology of an American engine company. It is named after a mythical American cryptid, but fights its battles in the very real heat of the African Sahel. Technically, it is a competent, if uninspired, implementation of the V-hull MRAP concept. Its welding is solid, its steel is hard, and its geometry is sound. Its weaknesses lie in its automotive refinement, power-to-weight ratios that border on anemic, suspension that punishes the crew, and cooling systems that struggle against the equator. Yet its strategic success is undeniable. Nobody expected the Bigfoot to become the workhorse of African counterinsurgency, but it achieved this by being available, affordable, and effective enough to save lives. It represents a pivot in Chinese exports from mass-wave tactics to protected mobility. For the Nigerian soldier in the Sambisa forest, the pedigree of the engine or the lack of independent suspension matters little. What matters is that when the mine detonates, the V-hull holds and the Bigfoot keeps moving. In that regard, this unassuming truck has left a very large footprint indeed.